Alright, Chapter 1. This will deal with the introductory concepts and definitions. This, first segment of it will basically just cover our SI units, English units, and, what we have for a system, a control volume, and, what our view is of thermodynamics from either a macro or a micro type view. So, what do I expect you to get out of, shall we say, all of Chapter 1? And that is to demonstrate the understanding of, several fundamental concepts. Critical is the use of systems, a closed system, an isolated system, an open system. They're all very important. Control volumes, boundaries, and surroundings are very, very important, and they're usually just kind of presented in square blocks, but it's something that you really need to consider. Another category is the property, state, and process. A property is a specific item that exists at any given state, and the process is the pathway that you are going from one state to another. You need to be able to understand these. We have properties that are both extensive and intensive type properties, so we need to kind of get those in good shape. We also have to deal with SI units and English units. Most people prefer the SI unit. I wish everybody did, but that isn't the situation that we have right now. We will need to deal with temperature. We deal with temperature in absolute scales of Kelvin and Rankine, and relative scales in Celsius and Fahrenheit. We need to be able to apply a problem-solving methodology in order to address each of these problems, and that's what we will do. So, first statement, what is a system? It's whatever we want to study. So here, I've just drawn this as a square block, but it could be anything, and it's we who choose that. The surrounding is everything that is not part of the system. That's the definition of the surrounding. And the boundary is an infinitely thin perimeter that encloses the boundary. A closed system, it always contains the same matter. This is a closed system. It's closed because the system itself is defined in this area. It does not include air that might come in through a valve or exhaust that might go out from a valve. It doesn't include that. With a system, there is no mass transfer across the boundary. That's an important distinction between a system and a control volume. An isolated system doesn't interact with the surroundings in any way, which even means that, during an explosion here and increased temperature, there is no heat transfer leaving that region. So this would never be an isolated system. So the isolated system has no exchange with the surrounding at all. A control volume, again, it is something that we are defining. So here I've defined an entire cube that will encase the entire engine. The important point about it is that mass may cross the boundary. That's the difference between a control volume and a system. So here I have air coming in, I have fuel coming in, and I have exhaust going out as well as work going out. Those are important items. The macroscopic versus the microscopic view. You know, a microscopic view aims to characterize by statistical means the average behavior of the particles. It is statistical thermodynamics. We are not studying that. The macroscopic approach describes the system behavior under what they consider gross effects. But basically, we can use an instrument to measure what the pressure is or the temperature. And that is basically our engineering thermodynamics, which will be used in this course.